Welcome to Money Attitude.
Recently, we've been able to run programs fast enough to do something called a artificial intelligence model or a neural network, depending on how we say it. And then we're building chips now that run artificial intelligence models fast. And we have a novel way to do it at the company I work at. But lots of people are working on it. And I think we were sort of taken by surprise what's happened in the last 5 years, how quickly models started to do interesting and intelligent seeming things. There's been an estimate that human brains do about 10 to the 18th operations a second, which sounds like a lot. It's a billion operations a second. And a little computer, processor in your phone probably does 10 billion operations a second. Ish. And then if you use the GPU, maybe 100 billion, something like that. And big modern AI computers like OpenAI uses, or Google or somebody, they're doing like 10 to the 16th, maybe slightly more operations a second. So they're within a factor of 100 of a human brain's raw computational ability. And by the way, that could be completely wrong. Our understanding of how the human brain does computation could be wrong, but lots of people have estimated based on number of neurons, number of connections, how fast neurons fire, how many operations a neuron firing seems to involve. I mean, the estimates range by a couple orders of magnitude, but when our computers got fast enough, we started to build things called language models and image models that do fairly remarkable things.
So what are computers doing now that you found surprising because of this increase in speed?
Yeah, you can have a language model read a 200,000 word book and summarize it fairly accurately.
So it can extract out the gist.
The gist of it. The computer does those operations on representations of information, ones and zeros. It doesn't understand them at all. Like a computer has no understanding of it. But what we call a language model translates information like words and images and ideas into a space where the program, the ideas, and the operation it does on them are all essentially the same thing. Right? So a language model can produce words and then use those words as inputs. And it seems to have an understanding of what those words are. Which is very different from how a computer
I'm curious
operates on data.
About the language models. I mean, my sense of, at least in part, how we understand a story is that maybe we're watching a movie, let's say, and we get some sense of the character's goals, and then we see the manner in which that character perceives the world, and we, in some sense, adopt his goals, which is to identify with the character. And then we play out a panoply of emotions and motivations on our body because we now inhabit that goal space, and we understand the character as a consequence of mimicking the character with our own physiology. And you have computers that can summarize the gist of a story, but they don't have that underlying physiology.
First of all, it's a theory that your physiology has anything to do with it. So in an AI model, so you can easily have a set of goals. So you have your personal goals. And then when you watch the story, you have those goals. Yeah. So you put those together. Like, how many goals is that? Like the story's goals and your goals, hundreds, thousands? Those are small numbers, right? Then you have the story. The AI model can predict the story too, just as well as you can. As the story progresses, it can look at the error between what it predicted and what actually happened. And then iterate on that.
Right.
So you would call that emotional excitement, disappointment,
anxiety. Yeah,
perhaps.
Definitely. Well, a big part of what anxiety does seem to be is discrepancy.
Like some of those states are manifesting in your body because you trigger hormone cascades and a bunch of stuff. But you also can just scan your brain and see that stuff move around.
Right.
And the AI model can have an error function and look at the difference between what it expected and not. And you could call that the emotional state.
Yeah. Well, I just talked with the...
And that's speculation. But
No, I think that's accurate.
But we can make an AI model that could predict the result of a story probably better than the average person. And what they see today is the capacity of the models is, if you say start describing a lot, it'll make sense for a while, but it'll slowly stop making sense. But that's possible. That's simply the capacity of the model right now. And the model is not well enough, grounded enough in a set of, let's say, goals and reality or something.
I mean, one of the things that what you just said makes me wonder is, imagine that you took Shakespeare and you took Dante and you took like the canonical Western writers and you trained an AI system to understand the structure of each of them. And now you could pull out the summaries of those structures, the gists, and then couldn't you pull out another gist out of that? So it would be like the essential element of Dante and Shakespeare. And
when you train a model to know something, you can't just look in it and say, what does it know? You have to query it. Right? You have to ask.
Right.
Right. What's the next sentence in this paragraph? What's the answer to this question? There's a thing on the internet now called prompt engineering. And it's the same way. I can't look in your brain to see what you think.
Yeah.
I have to ask you what you think. Because if I killed you and scanned your brain and got the current state of all the synapses and stuff, A, you'd be dead, which would be sad. And B, I wouldn't know anything about your thoughts. Your thoughts are embedded in this model that your brain carries around. And you can express it in a lot of ways. So all information has structure. It turns out that some of the deep structure of images and actions and words and sentences are related. Mm-hmm. Like there's actually a common core of, like, imagine there's like a knowledge space. And sure, there's details of humanity where, they prefer this accent versus that. Those are kind of details, but they're coherent in the language model. But the language models themselves are coherent with our world ideas. Mm-hmm. And humans are trained in the world just the way the AI models are trained in the world. Like a little baby, as it's learning, looking around, it's training on everything it sees when it's very young. And then its training rate goes down, and it starts interacting with what it's learning and interacting with the people around.
But it's trying to survive. It's trying to live. It has the infant or the child has.
The neurons aren't trying. The weights in the neurons aren't trying to live. What they're trying to do is reduce the error. So neural networks generally are predictive things, like what's coming next, what makes sense. How does this work? And when you train an AI model, you're training it to reduce the error in the model. And so babies are doing the same thing. Like they're looking at stuff go around, and in the beginning their neurons are just randomly firing. But as it starts to get object permanence and look at stuff, it starts predicting what will make sense for that thing to do. And when it doesn't make sense, it'll update its model. So
basically, it compares its prediction to the event, and then it will adjust its prediction. So in a story prediction model, the AI would predict the story, then compare it to its prediction, and then fine-tune itself slowly as it trains itself.